Kirchhoff's laws. Kirchhoff's first law is that the sum of the currents entering any junction is always equal to the sum of the currents leaving the junction. So for example, in this simple junction we have I1 entering, I2 and I3 leaving, and so I1 must equal I2 plus I3. This is a simple consequence from the conservation of charge, that as no charge is going to enter or leave the wires, whatever comes along here has got to go up there or along there. This leads to the current being the same all the way around a series circuit and being shared between the branches of a parallel circuit. Kirchhoff's second law states that in any closed loop in a circuit, the sum of the EMFs or electromotive forces is equal to the sum of the PDs or potential differences. This comes from the law of conservation of energy, as the EMFs are putting energy into a circuit, whereas the PDs are where the energy leaves the circuit. So applying Kirchhoff's first law to this simple circuit, any current leaving the power supply here must pass through ammeter 1, resistor 1, ammeter 2, resistor 2, ammeter 3, and come back to the power supply. So the current is the same all the way around a series circuit, and ammeter 1 is the same as ammeter 2 and the same as ammeter 3. Voltmeter 1 here will read the EMF of the supply, the energy coming into the circuit. Voltmeter 2 will read the potential difference across resistor 1, and voltmeter 3 the potential difference across resistor 2. The energy coming in, or the EMF here, must be equal to the sum of the potential differences here. That is Kirchhoff's second law. And so that tells us that the potential difference will be shared between the components in a series circuit. For example, if we had an EMF of 6 volts, and if voltmeter 2 read 4 volts, voltmeter 3 would read the remaining 2 volts. So the 2 volts plus the 4 volts coming out must equal the 6 volts coming in. Applying Kirchhoff's first law to this simple parallel circuit, the current coming down here through ammeter 1 must either go through ammeter 2 or down here and through ammeter 3, joining up again to go through ammeter 4. So ammeter 1 will have the same reading as ammeter 2 plus ammeter 3, and that will be the same as reading ammeter 4. So from Kirchhoff's first law we get that the current is shared between the branches of a parallel circuit. The current coming down here is shared between these two branches. If we know that this is 3 amps and this is 2 amps, this must be 1 amp. Kirchhoff's second law tells us that the EMF across the power supply here, read by voltmeter 1, must be equal to the potential differences if we go around this loop, that is V2, or if we go around this loop, being V3. So the EMF V1 must be equal to the potential difference V2, and also equal to the potential difference V3. So from Kirchhoff's second law we have that V1 is equal to V2 and equal to V3. The potential difference is the same across each branch of a parallel circuit, and that is equal to the EMF of the supply.